Hey guys, and welcome to a new video in this Computer Vision and OpenCV tutorial. In this video we're going to talk about histograms and how we can use histograms in computer vision and why they're a good thing to learn. So yeah, first of all we're going to talk about one-dimensional histograms. So for example, let's say we have a grayscale image and we want to create a 1D histogram of that grayscale or image. And then we use histograms to get some kind of global information about the picture. So over here to the right we can see that we have drawn a histogram of the picture here to the left, which is a grayscale picture. And then we use a histogram here, for example on the x-axis here we have the intensity in the picture, and then up on the y-axis here we have the numbers of pixels. So the intensity down here would be 0 to 255 because we have a grayscale image with only one channel. And then at some intensity here we have a numbers of different pixels with that intensity, and then we can draw a histogram here that shows the numbers of pixels with a one intensity. So over here in the picture we can see that we have a lot of pixels in the mid values here, around here for example 50 to 200, and not that many pixels up in 255. So we don't have that much white pixels in the picture here, and a bit more gray and dark pixels. And we can use histograms to get some useful information for classification. We can, for example, say that we have some different kind of let's say these bolts were red and the background was white, then we can classify those red bolts out because the intensity would be different in those kind of areas where the intensity of the pixels would be different compared to all of the other pixels in the image. So it could be useful for classification, but not certain classification. So let's say we want to say if it's as a dog or cat or something like that, or any other object, it's not really useful for that, more just classification or where some object is in the image, because we don't get this unique information here. So we don't know what is in the picture. We just know that there's something in the picture and it changes in intensity, and a numbers amount of pixels have some certain intensity, and then we can do some classification from that. So in OpenCV, if we want to do 1D histograms, we can use the built-in function here, calc_hist. So it will calculate the values for the intensity of the pixels in the image, and then you'll get that as an output. And we do this by just in any other function we're creating this mat object here, which is just a matrix of the image that we want to calculate an histogram of. And then we need to set the float range here from 0 to 255, as we just saw in the last slide here. So it's the range from 0 to 255 because we have a grayscale image with only one channel. And then we just set it up here, and then we use the function here where we just plot in all the information that we have, and we need the parameters that we need to pass the function. And then we calculate the histogram for the image, and then we can use the CV line to draw the actual histogram, which we'll show in later in this video with an example. So when we're doing 1D histograms, we can also talk about smoothing, as we talked about in the last video, because when we have some noise on an image or anything that can disturb our calculations, we want to smoothen out our image to get a more precise result. And we can also do this with histograms, so we get a more reliable and more smoothened out histogram, as we talked about in the earlier video, where we can just take some mean value or some average values. There's different kind of methods to smoothen up images, and we can do the same here for histograms. So you can go check the previous video out if you haven't seen it, about smoothing and what we can use it for, because then we can find the local minimum maximums and just deal with noise when we're doing smoothing on our images and then on our histograms as well. But we can smoothen our histogram here. Down here there's a function in OpenCV as well, where we can smoothen out the histogram that we have calculated. So here we have the mat object again, the matrix object again with our smooth histogram, and then we just have a for loop that just runs through all the rows in our histogram, and they just smoothen it out at each pixel like each pixel or like each value in our histogram, and just smoothing out the histogram, and then we have done the smoothing and we have reduced or dealt with noise if there were any in our picture and histogram. So we can also have like a colored histogram. So in 1D histograms we can also have like these colored histograms where we then have 3 channels for the red color and the green color and the blue color, and then it will look like something. Then it will look like this, where we still have the intensity out on the x-axis and the numbers of pixels up on the y-axis, but then we just draw like 3 different lines with each color. So we can see here in the picture that we have a lot of like red pixels with this intensity here in the picture, and also like in the end here. So it will be like we have detected the red balls here in the image here and the intensity. So like these colors here down here should be like the values that we can see here in the histogram, and then the red ball in the front here should be like the red spike here in the end, because we get like a higher intensity with this ball here compared to the other balls. So when we're using color histograms, we can use them more for like classification and stuff like that, because we can actually like see what we have in the picture, but not like a unique solution to like a classification. And then we can also have like the other color models that we talked about in the first video here, and make histograms of them as well if they're in some cases like they're useful. And for example here we can see with the HLS, we can see that the green here at with this intensity here, it just takes like all the green values here in the image, and we can see like the green value is really a lot represented in this image. So we can use like these different kind of models, color models, and you can like choose between them and find like the best one to like, so you can get the most useful information from your picture when you're dealing with histograms. So it's useful to like try out different kind of color models, as well as we also talked about in the first video. So to do like the color histograms in OpenCV is like it's kind of like with the grayscale histogram as we just talked about, but now we just have like a vector with all these 3 channels, and we still have to give it a range from 0 to 255, which is the intensity of the pixel values. And then here we just have a for loop that run through like all the channels in the picture, and then calculate the values for the histogram for each of the channels. So it's pretty much the same as with the grayscale one, but now we just have 3 channels instead of 1 channel. And then we again use the CV line to draw the actual histogram when we have calculated the values for the histogram. So we can also have like 3D histograms where like the channels are not independent as in the previous histograms, and we can see down here that now we get a 3-dimensional histogram. So instead of we just have a graph like in 2D, we now have the 3D the 3 dimensions, where we have like these circles here from the picture here that can be like classified in a 3-dimensional space. So when we're using like 3D histograms, we can use them more for like clustering our data and like more like separating our data and get some information about that. So in 3D histograms, we have like better discrimination that comes from considering all channels simultaneously. So we look at all channels at the same time, and then we draw like our 3D histogram where we can extract some information from that, like for example like a clustering, or if there's any correlation between some of the values in our picture. So we can also like do this with 3D histograms where we reduce our quantization to like 6, 4, and 2 bits, and we talked a bit about like quantization of images in the first video. But down here we just see again when we have like these 3D histograms, we can have like the blue, red, green, and then we have like the different kind of frames in the 3 dimensions. So if we want to do 3D histograms in OpenCV, we again have to like set up our channels, and then like run through all of our channels, and then we have to get it into like a 3D dimensional like a 3-dimensional space instead of like 1-dimensional. And we do like with this channel range and down here, where we just instead of having 1 channel range, we have like 3 channel ranges down here in this vector. So we have like 3 channels and we have 3 ranges, and then we just plot that into the function here, that like the built-in function in OpenCV calc hist, and then it will make the calculation for the histogram values in 3 dimensions when we set it up in this way here. So we can also talk about equalization, and we can use equalization if an image has insufficient contrast. Like let's say down here on the picture we can see that it is pretty dark to the left here, and it might not be clear like what is on the image, and then we can do like equalization, and then the histogram also changes. So we spread out more of the like we evenly distribute the grayscales as I wrote down here. So we just like spread out the values more, so we will get a brighter picture. And then with some image processing, we can get this picture here to the right, which is more clear what is in the image, and it's also like more brighter. And then we have done some pre-processing on an image, and our like and our operations on the image will be like better, and also for like visualization for the human eye. Like it's easier to see like what's going on in the picture compared to the one over here. So we can use like equalization for some kind of image pre-processing before we're doing our operations to like get a better and more like stable result, because like human can distinguish like 700 to 900 grayscales, where like a computer or like a camera can see like way more than that. So it's easy for like a computer to like do this equalization and do some operations with it, like compared to what a human can see. And then we just normally equalize only the grayscales, so luminance, because we often use equalization when we have this dark picture here that we want to light more up or like make it brighter. And if we want to do like equalization in OpenCV, we can see over here to the left that we have actually almost have a picture where we can't see anything inside. And then when we have done our equalization, we have the output image down here where we can actually see there's like some kind of like parkway with some trees and some buildings in the background, where up here we can't see anything. And we can also see like here on the histogram before equalization, like a lot of the values, like all the dark values, they're like at once, like the intensity is like at one space down here, so it's a really dark picture. But when we equalized our histogram, like we spread out the values even more, so like so the intensity gets spread out more, and we get a brighter image. And we can also see like on the cumulative distribution function down here compared to like the original CDF here. And in OpenCV, if we want to do equalization, we also just can use a built-in function here, where we have like this vector of the channels as on the previous slides as well, when we're dealing with histograms in OpenCV, if we want to do it in 1D or 2D or 3D. And then we can equalize the histogram here with this function here, where we just like give it the channels here, where we often, like as we talked about here on the previous slide, we often use the luminance channel. So often we convert our image to an LSS image when we're doing equalization, and then we use the L channel to do this equalization histogram. And then in the end we just merged our channels with the original image, and then we have the output image down here in OpenCV. We can also do histogram comparison, which is like a really cool feature in OpenCV and just in general, because then we can compare different kind of histograms together, and we can see like if we're able to take the same thing. So let's say here we have like a 100% like a one correlation on this image here. So if we take this image here, it's like the original picture, and then we can see like here we compare this histogram, or like this histogram to this histogram, and then we see like how much these histograms correlate to each other. And we can see that like we spotted a building here and we have a building here, so like the correlation is like pretty close to each other, but not again, because we have like some green grass here and some other colors here that might not be the same in histograms, but we still have like the blue sky up here and the building. So like a lot of the histogram, like pretty much like most of the histogram, like 78% of the histogram will be like the same as over here. And then we can do it for like other images as well, where for example down here we have like the worst correlation, because we have some green water down here, we have like not the same building and stuff like that. So this histogram down here, like it doesn't really correlate that much to the histogram up here. So we can use histogram to compare images as well and see like if this building is the same building as something else. So this was more about like how we can use it for like object detection or some different kind of classification. So like we can classify these images that they are actually like buildings or something else like that, like the sky or water and stuff like that, because the histograms will be like really like they will be correlating to each other. So this is just like to give a fast overview over like correlation, like what it is, and it's just like how good some data matches to other data. And we can see down here, like if we have like a correlation of 1, then it is like just a line here, and it is like a pretty like tight line, like all the data points is on the same line here, and we have then say we have a correlation of 1. And then if all of the data is not correlated or they're just split out, we have a correlation of 1. Or if it's like still all the data points is like still close together, but in the opposite direction, we have a correlation of 1. And then we also have some other figures where we can like give the correlation and talk about like it's more like how we compare, like it's just a metric of how we can like compare images of the like correlation coefficient. So if we want to do this histogram comparison in OpenCV, we first have to like normalize our histograms of the two like histograms that we want to compare, because then we get a value from 0 to 1, and then we can compare those values. And then we have some different kind of like metrics that we can set up to show like how good our comparison of two histograms are, and then we just use the built-in function here in OpenCV, which is just called like compare histogram. And then we give it the histogram 1 and histogram 2 that we want to compare, and then some metric that we want to like see how good our comparison has done. In this case here, we're just using the correlation that we talked about in the previous slide, but we can also like use some other algorithms that you can go look up. But in this case, we're just using correlation. We can also use like histogram back projection, and we use this when, for example, let's say it's a better approach to selecting colors, and this is more like a supervised like approach or algorithm, because over here we have like a picture of people, and then we can see like we have like some kind of like extracted that information of the skin color from a human, and then we can like extract that information and do some object detection from that. So it's supervised learning, because we have to like say that these colors or like these pixel values are similar to human skin color, and then do some extraction of that information and try to like resolve it. Like the result would be a probability image which indicate like the similarity between the image and the sample set, and then our sample set would be like the pixel values that we have set or told the algorithm or program that these values are skin color values, and then the algorithm outputs a probability image, like for example down here that we can see like these white values will be like the probability would be like probably like skin color values, and then we can extract that information and do it and use it for some different kind of like object detection or recognition, not really the like recognition, but like object detection and face detection, skin detection, and so on. So we can also do this in OpenCV here, where we just like calculate the histograms again. So we can use like histograms for a lot of different kind of things in Computer Vision and OpenCV, and some of them are really nice features, and we're going to use them a lot. And then we can also use them like to compare stuff and do classification and object detection. So again, here we just calculate the histograms here for the picture, and then we normalize it, and then we just have a built-in function again from the OpenCV where we have like our normalized histogram, and we just call like this function here, back project, on the histogram, and then we input like the HLS image, like the original image that we want to do like a back project on the histogram here we have normalized, and then our output from that would be like a matrix of probabilities. So in this case here we have like an image here where the white colors here, white pixels here would be like the probabilities of that it is skin color here in the image. So we're now jumped into Visual Studio here, and I want to show you like some of the examples that we saw in the slides and how we can use the built-in functions from OpenCV to like draw a histogram in actual code, and what we can like extract of information from those histograms that we draw. So first of all, we're just going to like include all the OpenCV libraries and the standard library that we're going to use. And then we have like 3 different images here that we want to like extract some information from in histograms. And then we just like read the image in here with this imRead function here and resize the image. And then first here we just check like if the image is empty or like we couldn't load in the image, we just cout and return like exit failure. So we see our fail to load image if we can't read the image or something else happens to have it. So we have this vector here of matrix objects. So we will have like the BGR planes here. So we have like this these 3 channels here for our blue, green, and red planes, and it will be stored in this matrix in this matrix here, and then we just like split up our image into these like 3 planes here, like our BGR planes. And then here we set our range as we saw in the slides and in some of the code examples, where we set the range from 0 to 256. So like the upper boundary is exclusive. And then we just set here the hist range to the range here, so we have like a 1D histogram. If you wanted like a 3D histogram, we will need like 3 parameters or like 3 ranges inside of this vector or list here. And then we can go down here and use this built-in function here, hist, which will calculate the histogram values for our image, and then we just throw in like our plane here. So we calculate 1 because we have like 3 channels here, so we need to calculate for our like B histogram and our green histogram and our red histogram, the values for all those 3 values. So we do it with these 3 functions here, which is just like the standard functions with the built-in with the built-in function that we calculate our histogram value for. And then we go down here, and as we saw in one of the examples, we need to like normalize our data. So we normalize the data so we get values between 1 and 0, so they're like easier to operate with and plot. And then we use the line function here to actually like draw our values that we have calculated up here on a plot. So we use this line function here, which is like default values that we just plot in, like the histogram image that we want to plot on, and then like the points we want to plot on, and the values that we have calculated up here from our calc_hist. And then we just show the original image and the histogram that we have just calculated and drawn. So if we hit the local Windows debugger up here and we start with the first image here, we can see when it opens up, we can see like the picture here on the left is just like some outdoor like image where we have a lot of green and we have like some brown and some blue. And we can see here like it's a pretty light picture because like a lot of the intensity pixels are up here in the upper range. So we are operating with a brighter image, and we could say like, for example, like we don't need to like do our equalization on this image because it's already like pretty bright and stuff like that. So in this case here we can see that like there's a lot of green, like the intensity here like around like 180. Then there's a lot of like green values in that range, and it will probably be like the grass here. And then like the blue here, we can see like it will probably be the sky up here. So we can use the different kind of information, and we get like these 3 channels here, like for the red, green, and blue. And then these are just the values that we plotted with the line function, where the values were from the built-in function calc_hist. So if you just close this and we try another image here, just to show you some different kind of examples and like what different kind of ways the histogram can look like. So in this case here, I just take an image from a face detection video I did in Python earlier. So we can see here like there's not really that much intensity, different kind of like intensity images, like pixels down here. So like the histogram will be in the lower range because like a lot of there's not really like that many of the same pixel values here, so they will be like more spread out. And we have like a pretty bright image, which we also can see by not having a lot of spikes down here in the beginning of the intensity. So we're dealing here with a bright image. So if we don't even have our source image, like we can still like kind of see like, or like how our image works and like what the light conditions are in an image. And we can see down here, like we get some spikes here in the end with some of the values, which can be like my face, which has like a high intensity here in the red channel in the end, where we get a high peak. So the last image here, as an example, I want to show you is it's a picture as well, where we have like a bright image. So we don't need to like do our equalization on this as well, but we can see like there's a lot of different kind of swings like up and down here, so we get like a lot of different kind of changes in our intensity. So we can say, like for example, that we have a lot of pixels that are very bright up here in this range here, because we're dealing with a really bright picture. We can see like some of the bright values here, and in the sky, like they're probably like up here around, like they're close to white because they're up here, but then we get like some pixel values down here, which could be like some of the values here in the front of the car, and then these values down here could be like the grass or like the landscape in behind. So we can extract a lot of different kind of information from like histograms, and there can be like a lot of histograms, and if you have like dark images, you would have like a lot of intensity values down here, and then we could have used equalization with the built-in function that I showed you in this slide. But then you can just go like into C++ and just use that function if you have like a dark image, and then it will like spread out the like luminance and like the brightness to like a longer range in the picture, and then you will get a brighter image, and you can then do some operations or calculations or what you want to do with that image afterwards. So yeah, thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, and also like this video if you like this content, and so you show the YouTube algorithm that you want more of this in the future. So currently I'm also doing this artificial intelligence tutorial in C++ and an algorithms and data structures tutorial. So if you're interested in watching one of those, like you can go check them out. I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.